In section 9.1, we talked about how to solve systems of linear equations. So that's finding the x-y pair that satisfies two linear equations using a graph. So we found the place where the graphs intersected, and that was going to be the point that satisfied both equations. The graphing method isn't very efficient, however, because in order to use it, you actually have to draw the graphs, and that's something we didn't do back in 9.1. But if we were going to continue doing this, we'd have to start drawing some graphs, and that takes a long time, and it's not very useful. Luckily, there are two different ways to solve systems of linear equations using algebra, and we're going to talk about the first one today. So method 1 for solving a system was graphing. We're going to talk about method 2 for solving a system of linear equations, which is called the substitution method. The reason that solving a system of linear equations is tricky is because we don't know how to solve an equation that has two variables in it. We only know how to solve equations that have one variable in them. So the only way that we could find an ordered pair that works in an equation in two variables would be to guess and check. We could try an x and try a y and see if they work out. But we can, in order to solve a system of linear equations, what we can do is if we could turn this system of linear equations with two variables into an equation with one variable, we would be able to solve it. So what we're going to do is combine the two equations we have that are in two variables into one equation in one variable that we can solve. And we're going to do this using a process that is unsurprisingly called substitution. So here's what substitution hinges on. It hinges on the fact that we have these two equations. One is 2x minus 3y equals 4. The other one is x equals negative 9 minus 4y. And right now we have this equation that has x's and y's in it, and this equation that has x's and y's in it. But as you can see, the second equation is formatted in such a way so that we know that this expression, negative 9 minus 4y, is the same thing as x because it says x equals this. So what we're going to do is we're going to substitute it, so this is where the substitution part comes in, into this first equation for x. So when we make the substitution, we'll end up with one equation that's in just one variable. So here's what I mean. We're going to make this substitution, and we're going to get 2, and then instead of x, I'm going to put in this red, what I circled in red here in the second equation. So I'm going to put in negative 9 minus 4y. So instead of x, we're putting in that. And then I'll continue with the rest of the equation. Minus 3y equals 4. So now what we've done is we've substituted negative 9 minus 4y into the first equation for x, creating one equation in one variable. So now we can solve this one equation in one variable, just like any other equation that we've been solving all year. We'll distribute the 2 and get negative 18 minus 8y minus 3y equals 4. And then I'm going to combine like terms on this side of the equation. So I'm going to combine this negative 8y and this negative 3y. And I'm going to get negative 18 minus 11y equals 4. Then, next step is to add 18 to both sides of the equation. And we get negative 11y equals 22. Divide by negative 11 on both sides. And we get that y equals negative 2. So now that we've solved our new equation, we know that the y value of our ordered pair is going to be negative 2. However, we don't know the x value. Luckily, there's a really easy way to find this x value. We can look over here and see that we know how to find x. X is just equal to negative 9 minus 4y, and now we know that y is negative 2. So we can take this y equals negative 2 and plug it in here to find x. So to find x, we're going to plug our y value into the equation that tells us what x equals. So that's our second original equation, which tells us that x is equal to negative 9 minus 4 times whatever our y is. And we know that y is negative 2. So instead of y, I'm putting in negative 2. So then if we simplify this, we get negative 9 plus 8, which is equal to negative 1. So the moral of the story is that the x value of our solution is negative 1. Now that we know the values of x and y, it's very important to actually write out our solution. So our solution is going to be an ordered pair. So if we were looking at a graph, this would be the point where these two lines intersect. And our ordered pair is negative 1, comma, negative 2, always x, comma, y. So this ordered pair is the only ordered pair that satisfies both the equation 2x minus 3y equals 4 and the equation x equals negative 9 minus 4y. Now that we have our solution, negative 1, negative 2, the last thing we need to do is check to make sure it's right. So in order to do that, we're going to check our solution in both original equations. So our solution from the last page was negative 1, negative 2. And we're going to substitute that back into both equations because in order for it to be the solution to this system, it needs to work in both. So for the first equation, I'm going to do 2 times my x value, negative 1, minus 3 times my y value, negative 2. And when I do this, this is supposed to come out to 4. So that equals negative 2 plus negative 3 times negative 2 is 6. So that equals 4. So that's great. We got that one. That one's all set. Then our second equation, we should have our x value, negative 1, should be equal to negative 9 minus 4 times the y value, which is negative 2. So we've got to see if this works out to be the same on both sides. So this is negative 1 equals negative 9 plus 8. And luckily we can see that this is working out because negative 9 plus 8 is 1, negative 1. So you can see on this side we've got negative 1, on this side we've got negative 1. So this one also works. And we know that negative 1, negative 2 is definitely the solution to our system. So the great thing about these problems is that once you find your solution, you have a surefire way to know if you're right. If you get an answer, you want to plug it back into both original equations, and if it works in both, you know the problem's right. There's not even any guessing. Now, in this example, it was really convenient because this second equation, x equals negative 9 minus 4y, was already solved for x, so it was really easy to make this substitution up here for that x. Not every example that we do is going to be that way, so this is where they get a little bit harder. You could have an example like this one, where both equations have a and b on the same side. So a and b are just like x and y, so instead of looking for x and y, we're looking for a and b. And a and b are both on the same side of the equation. However, and so it's harder to make a substitution. However, we can fix this simply by solving one of the equations for one of the variables. So I think I'm going to pick to solve the second equation for a variable just because it looks pretty simple. And what I'm going to do is I'm going to solve it for a. So to solve it for a, I'm just going to subtract b on both sides and get that instead of having a plus b equals 16, I'm going to write that a equals 16 minus b. And the reason I did this is because now that I've got it in this format, a equals 16 minus b, I can take this 16 minus b and go up to my first equation just like before and make a substitution for that a. So now that we have one of the equations solved for one variable, we can proceed as usual to make our substitution. So what I'm going to do is I'm going to go to my first equation, so this a minus 2b equals negative 17. I'm going to substitute, just like I said I would, the 16 minus b in. So I'm going to do, instead of a, I'm going to write 16 minus b, and then I'm going to subtract 2b and get negative 17. So this is my new equation after substitution. Now what I have to do is solve it. So I'm going to simplify by combining these like terms, and I'll get negative 16 minus 3b equals negative 17. Then I'll subtract 16 on both sides. I get negative 3b equals negative 3. Divide by 3, negative 3, on both sides. And you get that b equals positive 11. So we've got our b value for this system. Now, hopefully remember from the example before that the way that we're going to find a, now that we have b, is to take this b and plug it in to this equation. So we're going to start out with, now we're going to find b. And to do that, we're going to use the equation a equals, I'm sorry, we're not finding b. That was a silly thing to say. We're finding a. We already have b. We're finding a. So to find a, we know that a equals 16 minus b. So we can make this substitution. 16 minus our b value that we already know, so 16 minus 11. And that you can already see how to solve. A is 16 minus 11, or 5. So now we also have the a value. So we can write that the solution to our system is 5, 11, or a, b. And usually the convention is to do the variables in alphabetical order. So if it was x, y, we know that the first number would be x, second number would be y. For a and b, first number is a, second number is b. Now that we have our solution, the last thing we have to do is check. So we'll check the first equation. We'll plug in 5, and then minus 2 times our b value, which is 11. So 5 minus 2 times 11. And that's going to give us 5 minus 22. And 5 minus 22, they're opposite signs, so we subtract and take the sign of the larger, and you get negative 17. So that's what we want. And then for the second equation, we need to do our a, which was 5, plus our b, which was 11. And when you do that, that's a really easy one. That comes out to 16, and that's what it was supposed to be. So we know that our solution is correct. So we can say that this solution, 5, 11, is right. And so this is going to be the one point where this system of linear equations intersects, the one point that works in both equations, and therefore it is the solution. So the last thing I'd like you to try to do tonight is try to solve one system of equations on your own. So I'd like you to, right now, pause your video as soon as I'm done saying this, and use substitution to solve this system. After you're finished, check your work. Once you're finished checking your work, please unpause the video and I'll have one more thing to say. So if you're hearing this, this means that you've hopefully taken the time to try to solve this system of linear equations, and you should have gotten one ordered pair as the solution and checked it. And if you did it right, you should have gotten the ordered pair negative 7, 22. So negative 7 for x, 22 for y. If you got this, great, you're done. Have a good night, and I'll see you at our next class. If not, please take a few more minutes, go back to your system, and try to redo your work and get your negative 7 for x and your 22 for y. Once you've done this, you're done your homework for the night, and we'll see you in class the next time. Good luck.